Today one friend asked whether I can show a simple circuit with the X trigger inverter IC, that is 74HC14. That is this IC you are going to see here. This is a 14-pin IC. It is Schmitt trigger inverter IC 74HC14. This is the IC. And you need a capacitor. Needed is this capacitor, electrolytic capacitor, which is 100 microfarad. And you need a LED and two 10 kilo ohm resistors. These are the 10 kilo ohm resistors. Circuit is very simple. To make this LED blink, and this will be the device which will make it blinking, and the timing will be depending on this capacitor and the resistor, RC coupled circuit. I'll start off by checking the components. This is the LED. You can see it is lighted up. The longer lead is connected to positive and shorter lead to negative. You can see here. And it is lighting up, means that the LED is functioning. Multimeter is in continuity mode. Now it is off. So the LED is functioning. I am checking the resistance of the resistor, which is supposed to be 10 kilo ohms. You can see that it is 9.91 ohms. That is you can see that it is 9.91 kilo ohms, because the range is in 20k range. So this is 9.91 kilo ohms. I am checking the resistance of the resistor, which is supposed to be 10 kilo ohms. You can see that it is 9.91 kilo ohms, because the range is in 20k range. So this is 9.91 kilo ohms. This is the resistor which I thought is 10 kilo ohms, but checking it is only 1 kilo ohms, because in the same range it is showing us 0.98 only. This is the reason why I said that I'll have to check the components first. So now I had to replace it. That was a mistake. Now I have got another 10 kilo ohm resistor, 9.92. So that's a 10 kilo ohm equivalent resistor. Actually, this mistake would not have occurred if I had checked the color code, but being a quarter watt resistor, most of the color codes are difficult to see. That is how the mistake occurred. Now I am going to check the capacitor. That was the surge current of the capacitor when I just touched the lead. Now I have placed the Schmitt trigger IC on the breadboard. This will be pin number 1 and this will be pin number 14. There is a notch here, that is how you identify. So this will be 7, and so it goes. And for this IC there are 6 gates, NOT gates. We will need only one pair of it. 1 and 2 will be the input and output of the first gate. We will use only that, and the power supply. 14 and 7 will be the power supply pins. So we need only those. Other pins will not be connected. This 10 kilo ohm resistor is connected between first and second pins through the breadboard. From there, the second 10 kilo ohm resistor will connect to the longer lead of the LED, and the shorter lead will go to the negative power supply. Positive pole of the electrolytic capacitor will also be connected to the pin 1 of the IC, and the negative pole will go to the negative part of the power supply. For that I will need a jumper wire. The jumper wire has been connected. When I connected the jumper wire, the LED lit up transiently because there was charge in the capacitor when we had tested it. Now pin number 14 of the IC has to be connected to the positive pole of the battery that I have connected like this. Pin number 7 of the IC has to go to the negative power supply. All these are connections to the negative power supply which I have combined together. Now the whole of the negative elements, that is all the negative wires should be connected to the negative part of the battery. I have connected here. The next step is to connect the battery. Connected the battery and you can see that the LED is blinking. So it's a successful circuit using the Schmitt trigger IC. Next we will see whether the blinking rate of the LED will change by changing the capacitor. When I pulled out the capacitor, the LED is lit continuously. Now I have put a 1 microfarad electrolytic capacitor. Apparently the LED is continuously lit. I am not sure whether it is blinking very fast because from 100 to 1 microfarad the blinking rate would have increased very much and it may be impossible for me to find it by my eyes. Now I have removed that 1 microfarad capacitor. I will try a different value. Now I have put a higher value, 470 microfarad. So you can see that blinking rate has come down. When you have a higher capacitance, it requires more charging time and naturally the blinking rate will come down. It has come down remarkably with 470 instead of 100 microfarads. Here you can see the pinout diagram of IC 74HC14. Pin 14 is the positive supply, pin 7 is the negative supply, and other pins correspond to the Schmitt trigger inverters 1 to 6. Of these, only pins 1 and 2 for Schmitt trigger inverter 1 are being used in the circuit. Finally, this is the circuit diagram. You can see 9 volt power supply, 10K resistors, LED, 74HC14. Regarding the capacitor, I had tried 4 values. I had shown 3 values only, 1 microfarad, 100 microfarad, 470 microfarad. In addition, I had tried 1000 microfarad also. The LED was continuously lit. So you can try other combinations between 100 and 470 for sure. There will be difference in blinking rate. So that will be an interesting observation for a demo circuit. The circuit is functioning like an oscillator and changing the capacitance changes the frequency of the oscillator. That is how we saw that with 100 microfarad there is one speed of blinking, and when it was increased to 470 microfarad the speed of blinking decreased as it takes more time to charge a higher value capacitor.